Hi, I'm Stuart from Fab Lab Maker Hub, and this is another in the pop-up Fab Lab series. Today we're going to be looking at the anatomy and maybe the physiology of a 3D printer. I have my very first 3D printer here. This is a PrinterBot Metal Simple. It's a good few years old now, and I built it from a kit. It came as kind of like a few different parts that you have to bolt together. So I just go over, what makes up a 3D printer. One of the first things is the printer bed itself. So this is where the actual model gets printed and built up layer by layer from the filament that feeds in. The print bed here is actually a metal plate, and it's covered with heat resistant tape that allows the plastic to stick to the bed. If you didn't have this tape, if you're just printing directly onto the metal, the plastic wouldn't stick properly to it. The other thing that this printer has, and I'll lift it up underneath and show you, is it has this metal foil plate here. Now this is actually a heater. This heats up the bed, and the reason for that again is to allow the plastic to stick much better to the bed. If it wasn't heated, the plastic would cool down too quickly and the model you're printing would literally just fall off the bed. So the underneath heats up, that heats up this bed to about 60 degrees, between 50 and 60 degrees depending upon the material you're using. And by heating up the bed, the plastic remains stuck while the print is in progress. Okay, moving on to the next parts. This part here, the red part here, and the sort of copper nozzle there, that is what's called the hot end. And it's obviously it's colored red for a reason, to let you know that that actually heats up. That is the part that heats up to about 200 degrees or more. There's a small kind of heater in there, heater element in there, and there is a chamber, a small chamber in there, in which the filament enters, gets heated, melts, and then it gets extruded out of the nozzle down below there. So that whole section there is what's called a hot end. The nozzle is about 0.4 of a millimeter in diameter. That is the standard diameter for most 3D printers of this type. You can get nozzles with smaller diameters and larger diameters, and the newer 3D printers allow you to change the nozzles and swap them out. Unfortunately, this one doesn't have that facility. Moving up, we have this section here. This is what's called the extruder. On this printer, this is what's called a direct drive extruder. So what that means is the filament enters the little hole at the top there. This large motor turns a cog around, which forces the filament through and into the hot end. So it goes directly from the extruder into the hot end. And now there's a different type of extruder, which we'll come to a bit later on, called a Bowden extruder. So again, there's a couple of different types. The kind of benefit of a direct extruder like this is that you can use more flexible filaments that aren't quite as rigid. Just next to our hot end there is something that not all 3D printers have, a leveling sensor. So basically, as the hot end moves up and down, this can sense where the bed is. So if you're trying to level the bed, get it nice and flat so that your prints print nice and evenly on the bed, this sensor can detect where the bed is and set the correct height. Okay, moving on to the other side. Again, large motors here. These motors control 3 dimensions there. Obviously the X dimension, the Y dimension, which is backwards and forwards, and the Z dimension, which is up and down. If we look underneath the printer now, we have our other motors, our 2 other motors, and this is the brain of the printer. So all of the motors are connected there, the 3 motors, the X, Y and Z, and the motor for the extruder. And essentially this is a little mini computer that's running kind of custom software. We connect up the computer via just a standard USB port there. Coming around to the front again, cooling on a 3D printer is very important as well, and we have a fan here that blows cold air down onto the print bed as it's printing. So as I was saying, the print bed heats up, so that sticks the print to the bed, but the subsequent layers we want to cool down quickly so that we have a nice solid surface for the next layer to be printed on. So this is where the fan on the side here kicks in, and it directs the cool air down onto the print head so that it cools down the layers as it prints. So essentially that's the anatomy of this 3D printer. Like I say, this is quite an old printer. I'm just going to move over to the other printer we have here and explain some of the slight differences. So this is a Ultimaker printer. Same type of printer as the other one, filament based. This one's slightly different in as much as it has what's called a Bowden tube. The other printer is what's called a direct drive, and this is a Bowden style printer. Again, it has the same thing. It has a print bed down the bottom here. This print bed has a glass plate on it. Obviously the idea with a print bed is that you want your surface to be as flat as possible, and obviously glass gives a nice kind of flat surface. This print bed is also heated as well, so again it heats up in the same way as the other one. We have our hot end here with our nozzle, and this printer actually has the ability to swap the nozzles just by unscrewing them and screwing new nozzles in, so that's a nice feature. The cooling on this one, it has 2 fans, one on either side, so again that's a bit of an improvement over the other printer, which just has 1. The difference here then is this tube. This is a Bowden tube. So essentially the filament gets pushed up this tube, and if I show you around the back, the extruder on this machine is situated on the back here. So the filament here gets put on the back, it gets fed into the extruder here. The motor turns around, forces the filament up the tube, and then down into the hot end. So the advantage of a Bowden tube is that you're separating out the extruder motor from the hot end. So you're taking that kind of mechanical motion away from the hot end, which leads probably to a kind of a cleaner print, because you don't get so much, movement and wobble on the hot end. The other key difference between this printer and the other printer is that this printer, the print bed actually moves up and down rather than the hot end and extruder moving up and down. Again, that can lead to cleaner prints, because the other printer, if the hot end is moving, that can lead to maybe a little bit of wobble as you're going up and up and up, whereas this one, the hot end remains fixed in one height and the print bed moves up and down. This one can be connected up via USB to the computer, and also using a little memory card. This one also has a nice little LED panel there so that you can control some of the settings from the front with this scroll wheel. Kind of improvement, an upgrade from the other printer there, but obviously these printers cost a lot more than the other printers. These two printers are what's called FDM printers, that's fused deposition modeling printers, and they all use a roll of filament to print with. The other types of printers that are becoming much more widely available in the prosumer and sort of desktop market are some of these printers we have illustrated on the board here. This printer here by a company called Fab Lab, and these printers use a resin. Essentially it's a different type of printer that uses UV light to cure liquid plastic resin. But exactly the same kind of way that these printers print layer by layer, these printers also print layer by layer. You can see here in this photograph the model of the Eiffel Tower kind of rising up out of the sort of vat of liquid resin there. Different type of 3D printing, but essentially the process of going layer by layer is the same. Lastly, the other type of 3D printer, this ceramic printer, this one uses a slightly different method. It doesn't use an X, Y and Z. It uses what's called a delta arm, which is basically a kind of like a triangular gantry that can swing in any kind of like 360-degree movement. These printers are used to print ceramics. So you can feed clay into the printer. It's very good at making circular objects. As you can see, all of those kind of pots and vases were all printed using the ceramic delta printer. A few different styles of printers there, FDM, SLA and the delta style. So thanks for watching today, and I hope you enjoyed the anatomy of a 3D printer.